alcohol, alright, which is a subtopic from the topic called carbon compounds. Okay, my dear students, okay, let's look at the first part of alcohol. Okay, what is alcohol all about? Okay, we're going to see three scopes. Number one, alcohol is an organic compound with the general formula. Okay, what is the general formula of alcohol? It is CnH2n plus 1OH. The N begins with 1, 2 onwards, and the OH, which is hydroxyl group. Okay, and the first four members of alcohol's group, we have the first four members called MEPB. Methanol, ethanol, propanol, and butanol. Alright, and how do we remember that in short? Okay, methanol, 1 carbon, ethanol, 2 carbon, propanol, 3, and butanol is C4. And when you apply the formula, you will get the molecular formula. Okay, example, let's look at ethanol. They have 2 carbon. Apply the formula, you get the hydrogen 5 and OH. Okay, the structural formula, 2 carbon surrounded by hydrogen atoms and OH. Okay, the production of alcohol. How can we produce alcohol? Okay, let's look at one example of alcohol. We look at production of ethanol. Okay, 2 ways to produce. Okay, the first method is called as fermentation of glucose. The chemical equation C6H12O6. We add yeast, which provides zymase enzyme, and the product is ethanol and carbon dioxide gas. Okay, how do we balance it out? 6 carbon. We put a 2 here, we put a 2 here. So it's balanced. 6 carbons, 12 hydrogens, 12 hydrogens, and oxygen 6, oxygen 6. Alright, now, what is the second way to produce ethanol? We can do it by hydration of ethene. Remember, students, I've explained to you when I was teaching you about alkene. Alright? Okay. Hydration of ethene. Ethene added with hot water, the product will be ethanol. Some students may ask me, sir, what if I change this to propene? Then your product will be propanol. Alright? Okay. Now, for this second reaction, the factors are temperature, pressure, and catalyst. What about the temperature? 300 degrees Celsius. Pressure, 60 atmospheric pressure. And the catalyst is phosphoric acid. Okay, students, we have seen about alcohol till the production. Now we're going to look at the chemical properties as well as the physical properties. Alright, now the physical properties of alcohol. I write this in short form. Okay, the physical properties of alcohol. Number 1, colorless liquid. Is a colorless liquid. Okay, number 2, has boiling point of 78 degrees Celsius. Number 3, volatile liquid. Is a volatile liquid. And number 4, soluble in water. Alright? Okay, now the physical properties of ethanol. Colorless liquid, has boiling point of 70 degrees Celsius, is a volatile liquid, and it is soluble in water. Okay, we already looked at the 4 physical properties of ethanol. Okay, now we're going to look at the chemical properties of ethanol. Okay, how do we remember the chemical properties? Let me show you the easiest technique of remembering the chemical properties of ethanol. One, two, three. Okay. Now, how many chemical properties? 3. Okay. What are the 3? The first one, combustion. Number 2, oxidation. Number 3, dehydration. Okay, let's look at the first one, combustion of ethanol. Burns with blue flame and no soot. Remember, alcohols are good fuels because they burn with no soot, therefore no pollution. Alright, and the chemical equation, C2H5OH, burn in excess oxygen. Your product will be carbon dioxide and water. So remember, students, alcohol burn in excess oxygen, you will get carbon dioxide and water. Okay, now let's balance it up. Okay, burning, triangle. Okay, 2 carbon here. 6, we put a 3 here. Oxygen total 7, you put a 3 here, total up, you'll get 7. Alright, okay. So remember, alcohols are good fuels because it produces no soot. Alright? Okay. Next, oxidation is done by using oxidizing agents. Okay, what other oxidizing agents can be used? We can use acidified potassium manganate 7 solution, or we can use acidified potassium dichromate 6 solution. Okay, Remember, oxidation is done by using oxidizing agents. Alright. This time I'm going to use acidified potassium dichromate 6 solution. Okay, let's look at the chemical equation. C2H5OH added with oxygens supplied by the oxidizing agent. The product you will get carboxylic acid and water. So I repeat one more time, when we use alcohol and oxidation process produces carboxylic acid and water. Okay, if I use ethanol, my product will be ethanoic acid. And my dear students, I'll be showing you carboxylic acid later in the video, how to get the formula correctly for the students. Alright? Okay, now let's look at the example first. If I use ethanol, I will get ethanoic acid. And if I use propanol, then my product will be propanoic acid. Okay, now the agent used is written on the arrow. Acidified potassium dichromate 6 solution. Alright? Okay, and the final one is called as dehydration. It's done by using dehydrating agents. Okay, example of one agent, we can call it as hot porcelain chips. Alright, okay, let me show you one example of the chemical equation. I use ethanol, dehydrate, my product will be ethene and water. And write the name of the dehydrating agent on the arrow, hot porcelain chips. I wrote this in short form. Remember to write this in complete words in your exercises. Alright? Okay, now in techniques to remember it easily, combustion of alcohol produces carbon dioxide and water. Oxidation of alcohol will produce carboxylic acid and water. When I do dehydration of alcohol, I will get alkene and water. So the easiest way for all of you to remember, when I do combustion, my product is gas and water. When I do oxidation, my product will be carboxylic acid and water. When I do dehydration, my product will be alkene and water. So these are the three chemical properties of ethanol. Alright? Okay, my dear students, now we're going to look at carboxylic acid and their chemical properties as well. Alright, students? Carboxylic acid. Okay, when I mention carboxylic acid, what comes to your mind? Okay, let me tell you in summary. Carboxylic acid is a type of acid. Is a weak acid. Alright? Okay, you have heard that name before in your Form 4 in Chapter 7, acid and bases as well. Alright, carboxylic acid is a type of acid. What acid? Weak acid. General formula CnH2n plus 1 COOH. It has a group. Carboxyl, it belongs to carboxyl group. An example, ethanoic acid. Okay, let's look at the easiest way to write the molecular formula and the structural formula as well, and how to prevent from doing mistake when you are writing the molecular formula. All right, let's look at this. Eth, they have 2 carbon. Okay, remember the formula. The first carbon N begins with 0, 1, 2 onwards. All right, the first carbon in front begins with a 0. All right, for ethanoic acid, how many carbons do they have? 2 carbons. That means the first carbon 1. The back, there's already a carbon. So COOH. When the first carbon is 1, hydrogen 2 times N plus 1. How much will you get? So now, easy way. CH3COOH. 1 carbon, 2 carbon, total 2. Alright? Okay. What about the structural formula? 1 carbon, 3 hydrogen atoms, bonded with another carbon, with oxygen and a OH. Can you see, my dear students? When your molecular formula is correct, your structural formula definitely will be accurate. Alright? Okay, now let's look at the chemical properties of carboxylic acid. Okay, my dear students, the chemical properties of carboxylic acid in technique form. Okay, let me show you in a technique form. This is an acid. It reacts with the base. An acid reacts with the metal. An acid reacts with metal carbonates. And additional for this carboxylic acid, they react with alcohol. Okay, for today's lesson, I'm going to show you for all 4 in summary. Okay, acid plus base, salt plus water, acid plus metal, salt and hydrogen gas, acid plus metal carbonate, salt plus water and carbon dioxide gas, and carboxylic acid plus alcohol. Your product are ester and water. Okay, for today's lesson, we're going to do the first 3, and the next lesson, when I'm going to explain about ester, I'll be showing you about carboxylic acid is reacted with alcohol. Okay, students, carboxylic acid, can we choose ethanoic acid? CH3COOH. We choose a base, an alkyl, NaOH. OH. Your product will be a salt. Okay. Acid ionizes to give hydrogen ions. Alkali, OH. Joined. Your product is water. The salt, negative ion plus positive ion of a metal ion. CH3, COO, and A. Alright? And why there's no number when I'm going to take this and join here? Remember your chapter 3 from your form 4? When the charges are the same of numbers, eliminate. Join and write the product. Alright? Okay, let's look at for the metal. When I take carboxylic acid, I react with magnesium. And remember, my dear students, the metal must be more electropositive than the hydrogen ion. Therefore, it can displace the ion from the solution. Alright? Okay, now, the product will be CH3, COO, bracket 2, Mg plus H2. And students ask me, sir, why do we put a 2 here? Because the charge of magnesium is 2 plus. And hydrogen ions coming out H plus. So 2 coming out. So how do I balance it up? 2 hydrogen, only 1. So I put a 2 in front here. Alright? Okay, so now let's look at this. Where does this 2 comes from? Remember, when magnesium joins here is 2 plus and a negative of this. Different ionic charges we exchange. Alright? Okay, metal carbonates, the final one. CH3, COOH. When I add with sodium carbonate, my product will be salt. CH3, COONA. Students, I'm very sure you know why I've written like this. Remember the one I showed you above? When they are the same charges of ionic number, which is negative and positive here, we can just eliminate them. Alright? Okay, plus H2O plus CO2. Alright, now what about balancing for this? Okay, do I need to balance up? Yes, sodium is 2. How much will I put here? That's a 2. And carbon, 1 plus 2 plus 1. So total for how much must I put here? I will put here a 2. Alright? Okay, my dear students, now let's look at carboxylic acid in a close review. It displays the character of an acid. Reacts with base to produce salt and water. Reacts with metal to produce salt and hydrogen gas. Reacts with metal carbonates to produce salt, water and carbon dioxide gas. Okay, if I use ethanoic acid, my product will be sodium ethanoate. I repeat again, my product will be sodium ethanoate. If I use ethanoic acid with magnesium, my product will be magnesium ethanoate. And if I use ethanoic acid to react with sodium carbonate, my product of the salt will be called as sodium ethanoate. Alright? So, in a quick review, carboxylic acid is a type of weak acid. The general formula CnH2n plus 1 COH. Value of N begins with a 0. Example, we have ethanoic acid, and And chemical properties, they can react with base to produce salt and water. They can react with a metal to produce salt and hydrogen gas. They can react with metal carbonates to produce salt, water and carbon dioxide gas. And they can react with alcohol in the name of the process called esterification to produce ester and water. Alright, so my dear students, during this holiday time, please do revision of your carbon compounds up to carboxylic acid and ensure to finish up all the exercises as well. So stay safe and stay at home. Thank you.